does. Okay.
Awesome. Well, I see the recording going, so I think we're good to go.
Yeah, so let me do a quick introduction of you. So, hello everyone, this is Daniel Fedorin, and he is going to give a demo on the Chapel language server, and how you can use it in an editor to help you be more productive while you're programming in Chapel. All right, go ahead, Daniel.
Thanks, Michelle. Yeah, today I'll be looking at the language server and in particular the Visual Studio Code extension that uses it. So Chapel actually recently provides two tools, both of which I'll be demoing today. One of which is the language server, which helps with like code editing and navigation. And the other is a linter, which helps you write better Chapel code. So I'll get started with the language server, and what I have here on my screen is the file IO primer, or primer. I never know what to call these things. But what this is just a big file with some Chapel code in it, and I'll be showing you the sort of advantages that you get from having a language server enabled. So this file is pretty big, and you can see that there's lots of different variables going on, and there's these weird conditionals in places like if example is equal to 0. Um, and if you were reading this file normally, like without a Chapel language server, perhaps like in a text editor, like without any support, you'd have to be like grepping around or searching for example. But then, there's 27 occurrences of example, and some of these are in strings, so it's not exactly the easiest thing to do. But one of the most basic features of the language server is the ability to tie variables to their definitions. And so now if I hover over example, it will actually show me that example is a configuration constant that starts at 0. So in fact, I can even command click. So I'm holding down command and clicking example to go to the definition of this and read it. Though in this case, the example variable is not very well commented or documented, so we aren't even getting the most out of the language server here. However, one thing that is very well documented are Chapel standard modules. So if I hover over the IO module, which is being used on line 14 here, I will actually get the documentation for the IO module that I can read. So it goes on and on and on. There's lots of comments and discussions, and this is the same material that's mirrored on the web docs, but you can also get it in your editor. And I can also command click the IO module and go to its definition. So here I am now in the io.chapel file, which is the standard module, and I can scroll through and look at all this code. There are lots of linter warnings. We'll talk about this a bit later. So another thing I do sometimes, especially when I was developing some of these features in the language server, is find some other modules that are imported by the IO module, like here's OS or something, and then I click to that, and then I find another module, and I click to that, and then I find another module, and I click to that, and it's just kind of fun to traverse this. And what I'm doing now is proving to you that going to different modules and going to definition in any module works as you would expect. Now I'm going to close all these files that I've just opened. All right, so that was going to definition. Another thing you can do is, because the language server has now connected all the definitions of all the uses of the variable example to its definition, I can command click example here, its definition, and actually scroll through a list of every place where example is used. So I can go through here, and there's all sorts of conditionals here that compare example against a number. So it looks like the example is used to select which case of this code to run, and when the case is 0, it runs all of them, because all of these have example 0 in their conditional. And maybe I'm thinking like, well, example doesn't really seem like a very useful name for this. Like, I'm not really sure what this means, and if I was looking at this code, I wouldn't understand it at all. So perhaps what I can do is right-click this and click rename symbol. And now I can maybe replace this with example number, which isn't actually that much better, but it will work for the sake of demonstration. And now all the occurrences of example have changed, including the definition and everything, and this file is still valid. And all that was in a couple of clicks. So you might notice also that as I'm scrolling through this file, VS Code is showing me some warnings. And some of these are from the linter. And we won't talk through all of those right this second, but there are a couple that we can fix using this feature right now. So the file IO primer is relatively old, and it's been written before the Chapel conventions were completely solidified. So in this case, it has a record whose name starts with an uppercase letter. But the chapel convention nowadays is to use a lowercase letter for this. So we're getting a violation. It says camel case records is violated. So what I can do is right-click this file, click rename if I can find it, and then change it to my thing lowercase. And then this, you might notice, changed to my thing everywhere. And if I save the file, the warning is gone. So that's the various variable name features of the language server. They are only the beginning. So I'm going to go to the top now and look here at these use import statements. Another feature of the language server is autocompletion. So if I go down and I start typing something, so the IO module is being used here, which means all of the symbols in IO are actually available in the scope, including a symbol called IO mode. So if I start typing IO mode, I'm actually going to get it in my autocompletion list. And I'll just finish doing that and hover over it, and it will tell me, oh, IO mode is an enum, and then gives me all this documentation. And in fact, these are pretty smart. So I might also, I'm going to duplicate this here, rename this IO mode enum to OI mode. Hold on, I think it's like this. OI mode. Talking and typing at the same time is a bit difficult. So what I've done here is I've only imported the IO mode symbol from IO, but I renamed it to OI mode. And now I actually have the OI mode symbol in my scope because the language server is smart enough to process every use statement in the file to help you autocomplete. And in fact, if I hover over this, it will once again show me the documentation for IO mode. One way that I love doing this is whenever I'm working on GPU code, which you can do with Chapel, there's the GPU diagnostics module, diagnostics. And this one has some fun methods like start GPU diagnostics and stop GPU diagnostics and start verbose GPU. And it's really nice to just be able to get autocompletion for these because when you're prototyping GPU programs, you tend to use these a lot. And one other quick feature of this that I will show you is the symbols outline. So if I click these three dots here at the top of the file, it will show me all the variable declarations that are happening in file IO. And this includes temporary variables like var temp. It's going to have the example variables. So here's the example number that we renamed, epsilon. So actually, we're seeing these files here, or these variables here. And I believe these are all the basic features of the language server. And we'll come back to the advanced ones a little bit later. The trick with the advanced ones is that they rely on a prototypical feature of the Chapel compiler. So we're in the middle of a compiler rewrite, and these features rely on the compiler rewrite, which is not quite stable yet. So I recommend normally against using those advanced features by default. So we'll take a look at them later, but we won't prioritize them just yet. So instead, what I'm going to do is move on to the linter. And to do this, I will just create a new file and start writing some Chapel code. One really common issue that we've seen some Chapel programmers run into is confusion over Chapel's do keywords. So I can write a loop like this, for I in 1 through 10 do, and then I'll indent it a little bit, and I'll say hello. And then maybe I'll print out I, so it doesn't give me a warning about I being unused. And then this looks a lot like the code in Python, right? And there's this indentation, and you might think, or beginning users might think, well, to write something else out as part of this loop, I'll just write another line underneath. But the thing is that Chapel is actually not an indentation-sensitive language, so it's not like Python in that sense. And that means that how much space you put between a statement does not matter for whether or not a statement is included in a loop. So the only thing that makes this write-len a part of this loop is the fact that the do keyword takes the next statement and makes it part of the loop. And the do keyword only uses one statement. So this statement, as written, is actually not part of the loop. But this code looks like it would be. So if I save this file, I will actually get a warning about this. It says, hey, the indentation here is misleading because it looks like write-len world is going to be printed 10 times, but actually it's not part of this loop, so it's going to be printed only once. So I can fix this manually by dedenting this and saving, and then the linter stops complaining. But also, you might have noticed that when I was hovering over this warning, there's a quick fix button. And if I click quick fix and align the second statement to be outside of the loop, it even tells me what it's going to do. I click it, and it does that for me automatically. So if you did want to print both of those statements or run both of those statements 10 times, you would actually use a curly brace-based loop here. So, so this will print hello 1 world, hello 2 world, hello 3 world, all the way up until 10. Another similar warning that isn't as exciting is one about inconsistent indentation. So if you indent this right align by 4, but this right align by 6, you'll get a warning that says, hey, don't do that. This warning is more general, and so there's no quick fix available automatically. But the way to fix it is to either dedent this back to 4 or re-indent this to 6. While we're working with this loop, we can take a look at another warning in the linter that tends to occur relatively commonly, and that's not using the loop index variable. So here I have a loop, and it introduces a new variable called I, and it iterates 10 times. But it never actually uses I. So I is not mentioned in either of these two lines. So this could mean one of two things. Like you could have forgotten to use I, in which case you can use it in this, well, anywhere really, and the variable goes, and the warning goes away. Or maybe you actually don't need I, like you don't need to know which iteration of the loop you're in, because all you're trying to do is print hello world 10 times. So in this case, you can use the version of Chapel's loops that doesn't have this I in part. You can just delete it. And this still works and has the same semantics. And once again, if I hover over this, I can go quick fix and apply fix for unused loop index, and it will just remove it for me. I think this also works. It's actually been a little while since I've tried this, but it works in, let's see, 11 through 20, just for fun. So here I actually am zippering over two ranges. One is 1 through 10, and the other one's 11 through 20. And I'm using ij as variables here. And now both variables are unused. So I can apply the quick fix to I to remove it, and I can apply the quick fix to j to remove it. But then what's the point of unpacking this tuple of pairs of numbers 1, 11, 2, 12, and so on, if neither of them are used? So I can actually apply a quick fix again and make the whole thing go away. Of course, I might maybe only mention j, and in this case, this is the most simple that the condition or the iterand of the loop can be. Okay, and then we've already seen, actually, before I continue with that, we can actually see a couple of instances of this in the file.io primer that we've been looking at. In fact, problems. Oh, yeah. So here in file.io, there's actually 4 linter warnings that remain, and 2 of them are unused loop index. And if you go to these, we have that exact case that we were just looking at in the file. There's an I here, but it's not being used by any of this code. Since the file.io primer has been stable for a long time, it's likely that this code is correct, and what we're actually missing is that we don't need this I. So I will just go ahead and apply the quick fix to remove the I in both of these problematic cases. And then it's gone. Okay. And in fact, while we're here, there's only 2 remaining problems. And both of these are about control flow parentheses. So Chapel if statements don't actually need parentheses. So writing this is just as valid. And so this linter rule about control flow parentheses tells you that you can just remove the parentheses. And this also has a quick fix, which I will apply. And this happens also here with a while loop. A bit odder parenthesization here. Like I'm not sure what's going on here, but I can just apply the quick fix. And the parentheses are gone, and now this file has no warnings. You might notice that its name stopped being yellow. If I redo this, the name is yellow because there are warnings. Ugh. Okay, great. And the last thing, we've already seen it actually, so maybe I won't focus on it too much. But if you have something like a record and it's named not camel case because its first letter is capital, you get a warning. There's no quick fixes available because picking a different name is up to you as the user, but you can hit rename And well, now the name is inaccurate, but I removed the uppercase letter and the warning went away. All right, so that completes pretty much what I wanted to show with the linter. Although what I am going to do maybe is go to rules.py, which implements all of the rules that we've seen in the linter. And in fact, it's written in pretty simple Python code. So let's see, can I find one? Here's a function that checks for camel case. And then here we have, let's see. Here we have a rule that warns if variables are, warns for variables that aren't in camel or Pascal case. So Chapel variables can start with a capital letter, but they really shouldn't have underscores or anything like that. There are some exceptions to this rule, particularly if you're using, code from C or something, and then you don't really have a lot of control over the name. But otherwise, this rule applies, and this is written in what, I don't know, 7 lines of Python code, 6 lines of Python code. And a lot of that is fluff. Or not fluff, but it's a function declaration, which is pretty formulaic. And then there's this call to driver basic rule. I won't talk about writing your own rules in detail here. Just suffice to say that you can write your own rules in pretty simple Python using Chapel's Python bindings. And those rules can be executed as part of the linter. All right. So with that, I'm going to turn on the advanced features that I was talking about earlier that are still a little bit unstable. And as a result, so in fact, I'm willing to bet that when I click this checkbox, it's going to throw an error in VS Code, and I'm going to have to reload it. Part of the reason is that VS Code keeps some files open in the background, and some of the files that I've opened today during this demo were a little more advanced than the Dino Resolver can handle today. So yeah, I'm just gonna do it, and then just expect a little bit of red. Maybe not. I guess today I was a little too. I didn't have faith today, but we'll see. Well, it looks like it actually didn't do much. So I am gonna just reload the VS Code window to adjust the setting, and then look at this this file. Okay, so the experimental features are enabled, and we can look at it today and now. But before I go into why those features are helpful, I'll actually talk about a pattern in Chapel code that is relatively common and what motivated some of these features. So a pattern in Chapel code is to specialize the implementation of a function depending on the type of its input. So Chapel allows generic functions, and here the variable x is generic, so it doesn't have a set type. And this function on line 7 decides, does x support an efficient implementation of some operation? And it doesn't really matter what the operation is right now, but if it does, it executes the efficient operation, and otherwise it falls back to a slower but maybe more easy implementation of whatever operation we're looking at. And so here, type supports efficient operation is kind of silly. It just checks if the type is an integer. And I've implemented the efficient operation only for integers by returning 3.14. And I've implemented the slow operation for any type. Notice that x is generic here by returning 3.0 plus 0.14, which is definitely a silly thing to do because Chapel folds constants. So this at compile time, these are going to be the same pretty much. Like they're both going to be 3.14. But the only thing I'm doing here is giving you kind of the notion that this function is slower, even though in this case it really isn't. Okay, so you have this generic function. It picks either an efficient implementation or a slow implementation. But how do you know what it's doing for any particular type? So here I have 2 calls to generic function, one with x equals 42 and one with x equals 1.0. And 1.0 is not an integer. It's actually a real number. So this function is going to behave differently for them, but you can't really tell at a glance. And that's what these buttons are all about. So these generic functions in this file now have these little lenses at the top of them that say show instantiation. And these, you get one of these for every instantiation of the function that you have. So I can click this, And now I'm looking at the version of this function where the input x is an integer. So here it says x is an int64. And now I can see that this code on line 10 is greened out, which is the same color as comments in my theme. So what it's actually telling me is that this is unused. And what this implies is that type supports efficient operation is true when x is an integer, and it uses the efficient operation implementation. On the other hand, if I show instantiation with the second button, it's going to tell me that when x is a real number, the code on line 8 is greened out. And it's using the slow operation version instead. I can also click show generic to hide what's going on there. Some other features of the Chapel resolver that are similar to this are inferring types. So let's go back to this, right? So x is int64. Maybe I can declare a variable in this function that's like called y, and it's a tuple of x and x plus 1. And here, the resolver is actually telling me, even though I didn't have to do anything, that y is a pair of int64 and int64, because in this case, x and x plus 1 are both integers. And if I click show instantiation for the real number version, right away it tells me, hey, well, y is a real 64 here instead. And a fun one I can do is actually change this to 1.0. And this doesn't change the real case because x is already a real number and adding two real numbers is real. But if I go to the integer version, adding an integer and a real produces a real. So now this tuple is int real. And you get this for lots of things. Like I can write var z equals hello, and it'll tell me that it's a string. If I write a param, like my compile time value, and params in Chapel are values whose exact value is known at compile time. It will actually tell me, oh, param value is 42. That's not super helpful because I can see it right here. But if I multiply it by like 17 or something, it tells me the param value is 714. And then maybe I can have another param, is my value bigger than 10? And I'll use here it's not auto-completing. Is bigger than 10. And this is going to autocomplete and say param value is true. So all of these are hints in the editor that you get about the code that you're writing. But I'll delete this stuff. And maybe one last thing I will try to show, which is like extra experimental, is the call graph. So here I have this generic function that calls a call to the generic function with 42. For some reason, it's no longer here it is. Okay, just needed a little bit of time, or it needed me to click away from there, so it didn't move the code underneath me. So it calls generic function, and then it calls type supports efficient operation, and then it calls do efficient operation. And you can look at it at a glance, but maybe what you can do is right-click this and go to show call hierarchy. And let's see, are these outgoing calls? No. There we go. Okay, so VS Code can show you both incoming and outgoing calls, but what we want is outgoing calls. So here now we can look at this, and I'll maybe even zoom in a little bit. You can see the generic function, this call on line 14, calls type supports efficient operation and do efficient operation. And do efficient operation, well, these don't do anything. They don't call anything else. But let's see. I wonder, I think if I actually modify this to call +1, maybe it will show me that +1 is being called. But no. It's possible that I filter out operation calls like this. On the other hand, if I then do the same thing here on line 15 and show call hierarchy, it shows me a very similar piece of information, but in this case, it tells me that the slow operation is what's being called and not the fast operation. So I can look at the entire call graph at any particular location. And in fact, maybe what I'll do is I'll go to do efficient operation, I'll right-click it and show call hierarchy and flip it so that what I'm actually seeing are the callers of this. So who calls do efficient operation? Well, it looks like generic function calls it on line 8. And who calls generic function? Well, in this module, the call is on line 14. And that's probably my time. There's quite a few more features to the Visual Studio Code editor and the language server. So the language server and linter can both be used in your editor of choice. I'm demoing it today in Visual Studio Code because it definitely has the prettiest user interface, but I myself use NeoVim for my daily development, and these features work just fine in NeoVim, and that's my daily driver. Members of the team have tried this in Emacs, and pretty much any editor that supports the language server protocol can use Chapel language server and the linter. So thanks for watching the demo. Thanks for tuning in. I hope you can use these tools in your in your daily routine, I guess, to develop Chapel code more efficiently. And that's all the synchronous material I have prepared.
Thank you, Daniel. Yeah, that was really interesting and helpful. So let's open the floor for questions. Anybody have any questions for Daniel? I have one to get us started. Daniel, back when you were showing us the linter and the different rules for the linter, yeah, is there a way to configure which rules the linter is using?
Yes, there is. So the easiest thing to do, oh, maybe I'll even open the this is a kind of a little bit in the weeds, maybe. Uh, aha, here's the chapel check command that we use to lint some of the standard modules. And here, right here, we have this extra parameter to the linter called disable rule control flow parentheses. And what that does is says, hey, this rule that you have, you shouldn't be using it. I am only sharing my VS Code window, so I'm not sure that I'm going to have chapel check on my path right now. Oh, but I do. Excellent. Okay, well, that's even better. So chapel check lets you list all the available rules using dash dash list rules. So, and here I'm using the command line
So
chapel
chapel
check
check is
program.
the linter itself?
That's right, yes.
Okay.
So the command line program, um, uh, chapel check can be used to list all the rules that are available to you. And it's getting kind of line wrapped. Let me see if I can make it not look as cluttered. My font's also like really big, so it's wrapping. But look. So here are all the rules that my chapel check has configured, and the star means that the rule is enabled. So, and then if I didn't want a rule, I could even say disable rule, I don't know, let's say Boolean conditional statement, why not? And then, well, I guess I'm not sure that list rules is smart enough to oh no, these are default rules. Okay. So I can do list, I think enabled rules. Let's see, or is it active rules? Active rules. List active rules. And now disable or now Boolean lid and conditional statement is not there anymore. But if I take it out, if I just say chapel check list active rules, I'm not sure what happened up there. It's here. So basically you can enable and disable rules using the dash dash enable rule and disable rule on the command line, and in the settings for Visual Studio Code, because you're presumably using Visual Studio Code for this, you can use these arguments to chapel check here. So I can add item, disable rule, let's call it unused loop index because that's easy to show off. Unused loop index. And now I'm also going to disable the dyno resolver real quick because that's really shaky. And I'll stop using J. Probably have to restart chapel check to take this into account. No, I might have not typed the rule in right or something. But you know, when this is not me doing this live, what is the rule name? I'm gonna copy paste it to make sure. But yeah, these options can be used to control which rules are enabled and disabled. I'm not sure why it's being like this. At last resort, I'm going to reload my window. No space is allowed in the settings. Thanks, Jade, who just helpfully chimed in. I should probably turn on Do Not Disturb. Well, in that case, I'm not sure. That seems like a Visual Studio Code extension adjustment that we need to make. But in general, you can you have full control over which rules are enabled and disabled. Sorry for the long-winded answer.
Oh, no worries. So can you, I think you showed this at the beginning, but can you show this again? So to get all this functionality in VS Code, this is a VS Code extension, correct? And
yes.
And how does one, can you just step through how one gets that extension again?
Yes, it's really easy. So it's actually the only extension that I have in this Visual Studio Code instance, and it's called Chapel Language. So I think if I click this, it will take me to the store page. So that's the one. So Chapel Language, currently version 0.0.3. And all you hit is basically install it. I mean, maybe I'll even uninstall it, restart extensions so that, it's gone. Now, what is linter demo? It's blank. It doesn't even have syntax highlighting. I can hit install. I really think you normally have to reload VS Code for this, but I open this and the linter's going strong.
How can you tell the linter's going strong?
Because there's a warning right here.
Okay.
Yeah, it's
And
complaining
how can
about
you tell there is a because there's the little, okay.
Yeah, it's squiggle. It's only, the letter is only here. I'll make it
the
a
little
bit
squiggle under the
more
J.
text.
Right,
Yeah,
right.
yeah, it's more obvious this way. Yeah.
Okay, yeah, thank you for those. And does anybody else have any questions?
I have one. I was wondering how much of the, I guess, the standard library does the Dino resolver support right now?
The trouble with the Dino standard library is that it's kind of all or nothing, and it like all the standard library uses a lot of the standard library, and it uses a lot of relatively advanced Chapel features. So even when you as a user like just do write-a-len hello world, what's going on under the hood is like lots and lots of advanced Chapel code. And because of this, for the longest time, just getting this to resolve without errors has been a task that the Dino team has been working on fairly hard. And it works now, but suffice to say that the standard library is challenging, and I wouldn't bet on most files, like most standard library files, working. So file IO actually might work. I haven't tested it. We could try it now, but standard modules like IO and pretty much anything like we've seen like that is just not going to work. But this is an active area of work. There's some 5 or 6 of us on the Dino team working on the resolver. So expect that to change in the future.
Okay, cool. Thank you. I'm very excited to use this extension.
Thanks.
Yeah, I am too. I'm going to go into trying to use VS Code more than Vim.
Well, Michelle, I use Vim with language server stuff. So
I heard that you do. So, I may come crawling back to you. All right. So if that's all the questions people have, let me go ahead and stop the recording.